our pre-EE review, okay, this is just the third subject. We have AC circuit single phase part 1 basic principles. Okay, let us discuss some basic principles. We have alternating current. It is electric current that reverses direction periodically, usually many times per second. So, AC, so if we mean AC, it is an electric current, it reverses. It reverses, meaning AC, it moves back and forth, back and forth. Wherein the direct current, it moves only in one direction, Okay? So, usually many times per second. Okay. Generation of alternating current and voltages. So, where did we get, no? Or how does AC voltage produce? Okay, so we have the rotating a coil in a magnetic field. That's one. No, we are rotating the coil in magnetic field. Then we have to rotating a magnetic field within the stationary coil. Okay, just like in our generator, wherein we have a rotating coil, stationary field. Let's say this is the north and south pole. There is a rotating coil. Okay. And then there is what we call the rotating magnetic field in alternator. Basically, we get AC in alternator. So in alternator, so there is what we call the revolving field, revolving magnetic field. It's the field that the one revolving. No? Well, we'll have a detailed discussion when we go to alternator for this particular topic. Altering the direction of the magnetic field. Okay, so this is a basic principle. Okay, by the way, to our viewers, no, this is a review program. No, this is not actually a school setup, just like in college, wherein you have to discuss, no, everything, no, little by little. No, it's not that. No, this is a review program wherein this is just a review of what we have studied in college. So. But sir, what about me? I'm just an electrician. I want to become an engineer. This may be advanced study for you. You can watch this video again since we are going to upload this video in my channel. Okay, so this is a review program. This is not actually a long study of a particular subject. Just like, what do I mean? Just like in AC circuit. I remember alternating current circuit is around 58 hours when we are studying, right, in engineering, 58 hours. Okay, so 58 hours. In here, we are just going to study AC circuit around 8 to 12 hours, more or less, no? So, because this is just a review. This is not actually a a very detailed discussion, no? Okay, it's not that. So, this program is a review class, actually. Okay, a review class. So, well, anyway, don't worry. I'll try my best for you to understand the lecture. Okay? But this is already a big idea, no? You can consult, of course, your books, no? And you can take a look also some lectures in YouTube, no? Supplement these ideas. That will be good. Okay, so this is what we call a waveform. Okay, in particular, this is what we call a sine wave. No? Just like sine, cosine, tangent. This is the sine wave or sinusoidal wave. Where did we get this sine wave? We got this from the alternator in the power plant. If we have what we call an oscilloscope, that will you can see the sine wave there in the oscilloscope. Okay? It is a meter that shows the waveform of a voltage or current. So, you will see this sine wave, okay, for AC. Okay, so this is a revolving coil. As you see this one, so please close up this portion. So, this is a north pole and south pole. North to south pole. there is a magnetic field flowing from north going to south pole. This is the 0-degree position wherein, take a look here. Take a look here. So this is our coil. See? Let's say my hintotoro. Ano ba yung hintotoro? Forefinger. This is the forefinger, this one. So this is my forefinger. If I will move this from 0 degree to 90 degrees, okay? Let's say this forefinger, so we have here the magnetic field from north going to south pole. Okay? If we are going to move this coil, no, from 0 degree position to 90 degree, okay, until the magnetic field is in parallel with the plane of the coil. This is the coil and this is the plane of the coil. Now, in alternator, this is what we call the coil window. Coil window. So, let's see here. So, this is the coil. Okay. My forefinger here is this portion, the thicker part. This one, the thicker part. Okay. So, this plane is the coil window. This particular region, the space region is what we call the coil window. Okay? So that's the coil window. So as we move this from 0 degree to 90 degrees, there is a corresponding increase in voltage. This is what we call the instantaneous voltage or instantaneous value. From 0 to 90 degrees, there is an increasing rate of voltage. Okay? So, let's say from 0 to 90 degrees, there you are now. So, you have that thicker portion, which is my forefinger here. Okay? So, if we move again by 90 degrees, no, from 90 to another 90 degrees, which is 180 degrees, so, there is a corresponding decrease in voltage. Okay? Here. So, that will become 0. Then, another 90-degree turn, no, from this is 90 plus 90, so this is 180 degrees. Then another 90-degree turn, so there is another 90-degree turn, there is another increase, but negatively. Okay? There is a negative value here. This is the instantaneous value. Okay? Then, if you turn this another 90 degree, going back to the original position, just like this one, okay? So, this will go back to 0 here. So, there is a corresponding instantaneous values. Now, if we have AC, let's have first our DC. If we have a DC, direct current, let's say we have a battery here, we have a load resistor here. Okay, so we have here only one direction, let's say. Usually we use the conventional flow from positive to negative. So I have a very detailed discussion about DC circuit. No, you better go to my 32 videos, no, in my e-video book. So from negative to positive, this one, so only one direction, no, for DC. For DC, so this is the graph for DC. Let's say from 0 volt up to this volt. Let's say you have your 12 volts here. If you have your AC source, alternating current, so we have here our AC voltage, then we have here a load resistance. So we have here, during the positive half cycle, this is what we call a cycle. Again, this is a cycle. No? Okay. One cycle, we have two alternation. We have the positive alternation. We have the negative alternation. This is the positive alternation. This is the negative alternation. So, as you see here, okay, during the positive alternation, okay, the positive alternation, so the direction of current is in clockwise direction. During the negative alternation, so it goes back, it reverses. It reverses. Okay? So the tendency for the current or voltage, it moves back and forth, back and forth. Okay? It moves back and forth. Okay? So, this cycle is, if we mean cycle, it is a complete set of positive and negative values. Okay? If we mean a cycle, it's one. This is a cycle. Okay? That is one complete cycle. A cycle is a combination of positive alternation and negative alternation. Okay. The width of one cycle is 360 degrees. The half is 180 degrees. Okay? We have some basic terminologies. We have the waveform. It is the shape of the curve obtained by plotting the instantaneous values of voltages or currents as the ordinate against time as the abscissa. So, cycle, it is a complete set of positive and negative value of alternation of sinusoidal wave. Then the alternation is one half. Okay? So, if we mean alternation, it is half of a cycle. Okay? Half of a complete set of positive and negative values. If we mean alternation. We have the positive alternation, we have the negative alternation. Okay? Okay, I will go first with frequency. In the Philippines, we are using 60 hertz as our frequency. This is the number of cycles produced per second. The unit is in hertz. So, if we mean 60 hertz, let's say in the Philippines, we're using 60 hertz. In India, they are using 50 hertz there in India. So, if we mean 60 hertz, what do we mean by that? So, ano ibig sabihin nun? Okay, so we have here, meaning that 60 cycle at 60 hertz is what we call 60 cycle per second. Okay? So, meaning, if we mean 60 cycles, so we have 1, okay, 2, 3, okay, come on. You dictate to me. 3, 4, until we have 60. 4, 5, 6, okay, blah, blah, blah. Okay, this is the 60th cycle, let's say. Halimbawa, ito na yung 60th cycle, no? This is the 60th cycle. 60th cycle. So, meaning, from this point, no? From the origin here up to the last cycle, you only have 1 second depth. So, meaning, the current or voltage, it moves 60 times, no? It alternates, okay? 60 positive, 60 negative, okay? There are 60 cycles per second. Okay, so what about now the period T? Take a look here. What is our period T? Period T, it is the time taken in seconds by an alternating quantity to complete one cycle. To complete one cycle. Meaning, the period T, it corresponds only to one cycle. Take a look here. This is what we call the cycle. So, I will just get one cycle here. So, let's say there is a period T. This is a unit of time. The one cycle. Okay? Take a look here. We have here a cycle. I already draw a cycle here. Let's say this is this small cycle is this big, this is the cycle here. I just exaggerated here. So, meaning, this is what we call the period. This is the period T. The period T is simply equal to 1 over the frequency. 1 over the frequency. Take a look here, guys. So, 1 over the frequency, meaning, if we have a period T, we have here 1 over 60. What is 1 over 60 in our calculator? 1 divided by 60 equals, okay, so we have 0.016666, okay, so to round up 0.017, no? 0.017, no? Okay, or shall we say 1, 2, 3, approximately we have 17 millisecond. Okay, 17 millisecond. Actually, the cycle, so this is a factor in for the duty cycle of the circuit breaker. No? A design engineer would use this principle. No? Okay, so they consider the cycle, the duty cycle, circuit breaker, relays. So they are considering this as duty cycle. Okay, so if we mean period T, that is the time taken to complete one cycle here. That is only good for one cycle, meaning it is the time taken for positive and negative alternation. Okay? Instantaneous value, the magnitude of a wave at any instant of time or angle of rotation. Okay, so instantaneous value, of course, it is a value at any instant. Okay? So later, we are going to have some example here. Maximum or peak value. Maximum value of positive or negative attained by an alternating voltage or current. No? So we have two types of maximum. We have the positive maximum. We have the negative maximum. Okay, just like this one. So we have the positive peak, we have the negative peak value. So you have here 0 to pi, meaning 180 degrees is in pi radian. So this is 2 pi, so that is 360. Okay. So how do we represent this? Now, one of the representation is we have I of t is equal to I sub m sine omega t. Okay. I sub m sine, so 2 pi f times t. Because our omega here is equal to 2 pi f. Okay? 2 pi f. Okay, take a look here at my example on the whiteboard. Okay, let's take a look here. So if we have here a sine wave, we have a sine wave here. Okay? So this is our, I call this as starting point, this point. What is a starting point? This point, no? This is not the starting point. This is the starting point. I just call this as starting point. Okay? So, let us put here, by the name, starting point. Tawag ko lang naman sa kanya. So, I just called this as a starting point. Starting point, it is a point on the waveform wherein the next point or instantaneous value is on the positive direction. That is why this is not the starting point because the next value here is already negative. No? Negative na yung kasunod nito. Okay? So this is just a starting point wherein that is your theta 1. And your theta 2 here, take a look here. So this is 180 for half cycle. Another half cycle, another 180. Okay? So, take a look. Our x and y axis, no? So that is opposite. No? Baliktad siya ng Cartesian plane natin. No? It is opposite. No, with respect to our Cartesian plane. So, this is the positive, this is the negative. How do we represent that? How is that? So, number 1, they are all equal, these 4 equations. Meaning, this waveform can be represented by positive sign, positive cosine, negative sign, negative cosine. So, that can be represented by any of these 4. Example. Let's have an example here. If theta 1 is 30 degrees, so you have your 30 degrees here. Okay? List the equations of the voltage E. So, for number 1, just like this one. So, our equation E will be equal to E sub m, then sine E sub m is the maximum value. We have sine omega t. Okay? Theta 1 is positive 30. Okay? Because this is the origin that is on the left side, that is positive 30 degrees. So, ayan. Actually, the positive 30 is the location of the starting point. Okay? This is actually positive 30. That is positive 30 degrees. That is the location. Okay? What about for number 2, 3, and 4? 2, 3, and 4. How do we represent our E? Okay? From sine, going to cosine. Okay? So, E sub M sine omega t. Okay. So, this is the conversion. I mean, from sine to cosine, I'm sorry, that should be cosine. So, dapat cosine to. From sine to cosine, okay? Okay, from sine to cosine, plus 30 degrees, no? Plus 30 degrees, this is plus 30 degrees, so you have to subtract 90 degrees. Take note of this. From sine to cosine, you subtract by 90 degrees. So how much is this? So that will become E sub M cosine omega t. So positive 30 minus 90 degrees. So that is negative 60 degrees. But where is negative 60 degrees? That is the location of the positive peak value. Take a look here. So this is the location of the positive peak value. We have said that on the left side, that is positive. On the right side, you consider negative. So, this is already negative 60. That is the location of theta sub 2. Negative 60 degrees. There you are, here. Okay? In here, you have your negative 60. Okay, what about now for number 3? For number 3, we have negative E sub M. What about the negative sign? Sine omega t. So we have here plus 30 degrees. Okay, now, from positive sign, this is actually positive sign. This is positive cosine, right? From positive sign to negative sign, you subtract 180 degrees. So you have here E sub M. So that should be negative, guys, no? That should be negative. Should be negative E sub M. We have here omega t. So how much is this? Negative 150, right? Negative 150 degrees. There you are. Okay. Of course, the units are in volts. Okay. What about for negative cosine? From positive cosine to negative cosine, so we have here our E, negative E sub M cosine omega t, okay, plus 30 degrees. Okay. Oh, by the way, our positive cosine here, sorry, it's not 30. So let us correct this. For positive cosine, so we have negative 60 here. So put here negative 60 degrees. And then we have to put here negative. It should be minus 180. Shall we say from positive to negative? That's minus 180. You have to consider this. Okay, so therefore now, we have here our negative E sub M. So we have here cosine omega t. So that should be minus, how much is this? 240 degrees. 240 degrees. By the way, again, our positive 30 is the location of our starting point here. Okay? Our negative 60 here is the location of the positive peak value here. Our negative 150 degrees is the location of theta 3. Here. Theta 3. Our theta 4 here is the location of the negative 240 degrees, is the location of theta 4. So let us put here. So this is for theta 1, okay, the 30 degrees. The negative 60 is for theta 2. Negative 150 is for theta 3. And the negative 240 is for theta sub 4. So there you are. No? Okay? So theta 3 is negative 150 degrees and theta 4 is negative 240 degrees. So that's it. That is our equivalent waveform. Okay? This is the 4 equation to represent this waveform. Okay? So, let us continue our discussion. Anyway, you can, ito maganda dito, no? You can, this is the advantage, no? You can watch again and again in my channel, no? You can watch over and over again in my channel so that this will sink in to your mind, no? So, maybe first time you saw this lecture, it's not that easy to absorb, no? But if you watch again the lecture video, okay, that will be clearer, easier to understand. Okay. So we have here the phase angle theta. This is the phase angle, just like our example before, the positive 30 degrees. Okay. Our example here, the positive 30, were the location, of the starting point is at positive 30 degrees in our previous example. So this is our theta. It is the fractional part of a period or cycle through which the quantity has advanced or delayed from selected origin. Okay, so this is the phase angle. Phase difference. It is the difference between two phases. Usually, let's say we have the voltage phase, no? And the current phase, so they have a phase difference, no, of two or more alternating quantity of the same frequency which do not reach their maximum or zero value simultaneously. Okay? It's like this one. So if you are to take a look here, this is the phase difference. Always remember this formula in getting the phase difference. I'll show you the formula. The phase difference, theta phase difference, that is equal to theta leading, minus theta lagging. Okay? Then, you take note, the more positive is the more leading. Take note of that. The more positive is the more leading. So this is the phase difference. Here, the root mean square value. Actually, the root mean square value is equal to the square root of 2 times the maximum value. Square root of 2 times the maximum value. So that, if we are to get the maximum value here, no? I think I have to correct this. This one, there was a typographical error. So I will just write here. Okay, so the RMS value, take a look here. The root mean square is equal to the maximum value over square root of 2. Wherein, if you divide 1 divided by square root of 2, okay, so that is 0.707 or approximately 70.7%. No? 0.707 times the maximum value. That is our root mean square value. Okay? root mean square value. Okay, so please take note of this. Okay? Okay, it produces the same expenditure of energy when DC is applied to the same circuit for the same interval of time. No? So, well, if we mean root mean square, no? So, it says here, it for for an for the same circuit, no? For one circuit, I mean, no? If you energize this with DC, no? With DC, it says the root mean square produces the same expenditure of energy when DC is applied to the same circuit. No? So, when you apply AC or DC with the same circuit, no? So, meaning, you already reach the root mean square value. No? So, if they have the same energy, no? The AC source, the DC source, when it comes up to have the same energy, so you reach now for AC as the root mean square. Okay, what about the average value? The mean of all the instantaneous values of one half cycle. Let's say our waveform before all the positive values. What is the average of all the positive values here? Let's say you have your 60 hertz here. No? What is the average here of all the positive value here? What is the average? That is what we call the average value, or that is 0.636. In some books, they use 0.637 times the maximum value in some books. Okay? So, if we have here, I will exaggerate a certain waveform here. Take a look here, guys. You have a waveform here. Let's say, so let's say we have here this portion is our RMS value, whether it is voltage or current. So that is the RMS value, which is 70.7% or 0.707, of course, no, of the maximum value. Okay? This particular height, I mean, no? So, a lower value, okay, is what we call the average value. The average value. Well, actually, that is 2 over pi. 2 over pi of the maximum value, whether it is voltage or current. Okay? Whether it is voltage or current. So, or, if you divide 2 by pi, that will come up to be 63.7%. 63.7% of the maximum value. Okay? 63.7% of the maximum value. So, okay? RMS, the root mean square, 0.707. The average value is 0.637 or 0.636. Okay? So, what is 2 divided by pi? Okay? Well, that is 0.637 if you are to round off. Okay? Basically, if we mean RMS value, this is actually the AC value. AC value. If we mean the average value, that is what we call the DC value. DC value. Okay? Shall we say we have a tester, a multi-tester. You measured in the outlet. It registers there 236 volts, let's say. That 236 is the AC value, which is the RMS value. Okay? Let's say you have a direct current circuit. You have a battery or a rectifier, then you measure 12 volts, let's say, no? From your DC voltmeter. That is the DC value. DC value. Okay? Which is 63.7% of the maximum. Okay, so we have here the form factor, ratio of RMS value to the average value. So, okay. Shall we say we have here form factor? I'll just make it as FF. So we have here the ratio of the RMS value to the average value. Let's say for our sine wave, how much is this, guys? Come on. So if we have the RMS, which is 0.707 times the maximum value, the average is 0.637 of the maximum value. So the maximum will cancel out. Okay? That will cancel out. So how much is this? So, lumabas na to sa board exam, no? 0.707 divided by 0.637. So, that will be equal to how much? There you are. So, we have here 1.11. So, you have 1.11. 1.11 here. Okay? So, ito na, mga kawerpa, no? Okay, that is the board exam question, or actually that is a licensure exam here in our country, in the Philippines. So there is we call that as board exam, our licensure exam, no? Okay, in the US they call this as state board. Okay, so there is a question: what is the form factor of a sine wave? So the answer is simply 1.11. What about now for the peak factor? Take a look here, the peak factor. Peak factor, the ratio of the maximum value to the RMS value. So, take a look here, peak factor. So, we have here peak factor that is equal to, okay, the maximum value. Let's put here maximum value to the RMS value. The root means square. The RMS value. So, the maximum value, so put here maximum, and the RMS value is 0.707, right? Times the maximum value. So, the maximum will cancel out by algebra. Okay? So, we have here, just make it as 1 divided by 0.707. So that will become around 1.41. 1.41. So that is the peak factor of a sine wave. Okay? Sine wave peak factor. Okay, this is the summary of the waveform, the wave shape, RMS value, average, form factor, then the peak factor. Okay? So this is the summary. Okay? For sine wave, we already got the form factor, 1.11 and 1.41 earlier. For the half wave rectified, okay, so we have this. No, you may find this in electrical engineering books. Okay? So these are the different form factor and peak factors. No, for full wave, rectified, rectangular wave or square wave, triangular wave. Okay, let's go now to our sample problem. Okay, so we have here number 1 problem. An EMF E sub 1, 50 sine omega t, okay, and an EMF E sub 2, 30 sine omega t minus pi over 6. act together in the same circuit. Find the resultant EMF. Find the resultant EMF. Okay. So, I will first convert this equation, the trigonometric equation, no? This equation into polar form. But how to do it? Let's have first our E sub 1. E sub 1 that is equal to, so you have to put here 50. Okay? 50 and then sine omega t. So you have here plus 0. You have here plus 0. Okay? Partner, ha? Tanggalin mo yung ayaw mag-open camera, ha? Eh, baka maano tayo. Tanggalin mo na lang. Ayaw nila. Okay. So, we have here 50 sine omega t. So, we have here, since it is 0, so put here 0 degree. So, because this sine omega t is just plus 0. Plus 0. Automatic. Right? That's why I just put here 0. And E sub 2, 30 sine omega t minus pi over 6. Okay? So, our E sub 2 is equal to 30. Okay? So, it is pi over 6. Negative. So, carry over the sign. This is pi over 6. So, our E sub 2 now will be a 30 bar angle. Okay? So, that should be negative. So, what is our pi? Well, of course, that's 180. Then, divided by 6. So, that's simply 30 degrees. So, that should be negative 30 degrees. There you are. Okay? Of course, that should be in volts. Find the resultant EMF. You just have to add the two. So, E total, that is simply equal to E1 plus E2. So, we have here 50. Okay, this is in complex number. Okay? So, if this is 0 degree, okay, I'm sorry, this is a knowledge of advanced engineering mathematics. Okay? So, sorry, we don't have a pre-review in mathematics, no? So, I cannot discuss this with you in the full detail, no? So, a little idea, if we have 0 degree, you may not put 0 degree anymore here. Pwedeng wag mo nang ilagay yung kung 0 degree yung angle. Okay. So, plus 30 degrees. So, this is bar angle negative 30 degrees. Okay. Again, this is quite hard for our technician, no? Because of the advanced engineering mathematics. That's already a third-year subject in electrical engineering, in engineering course. Okay. So, we have to use our calculator here. We'll be using a little shortcut here using our calculator. Ito maganda, may calcio tayo, no? Okay. So, put your calculator in mode 2. Mode 2. There. So, by the way, I'm using the, actually, I'm using the Casio FX991ES. But this is not approved by the PRC. The one approved by the PRC is 570ES Plus. It's just the same function. The difference is just the solar power here. Okay? So, just like that one. That is the 570. And there is a second edition. No? Actually, we are selling this calculator. This one. This is the second edition. They just have the same function keys. No? They have same manual, I mean. Parehas lang, no? Okay? So, put your calculator in mode 2. Okay? Okay, pindutin lang, ha? Okay. Mode 2. The mode is on the upper right corner, no? That is near to the replay button. Mode 2, that is a complex number. So, put here 50. And then plus 30. Okay? Shift. You press now shift. Negative. For you to have this bar angle sign, you have to press shift. No? You have to press shift, and then the button of negative. That is above the RCL button, above number 7. That one. Okay? So, we have here negative 30 degrees. Okay? Of course, our calculator must be in the degree mode. Okay, so we have here equals. Then you press now, shift, 2, 3 equals. Okay, you press now shift, 2, 3. Okay, again, press mode 2. We have 50 plus 30. Okay, shift and then negative. That's negative 30 degrees. Then you press now equals. So the answer would be 77.5. 77.5. That is our total voltage. Okay? 77.5. So we have here sine omega t. That should be minus 11.168 degrees. Okay? So that will be our answer. So let's double check this one. So 50 plus 30. Shift. Negative 30. Equals. So you just have to press equal so automatic that you will have here your angle. Okay? Or you can press your shift 2, 3 equals. After you press this, you press equals. Then shift 2, 3 equals. Okay? So you will have this answer. Actually, in your calculator, this will register 77.45. Okay? So we have here negative 11.168 degrees. Okay? So that will be the answer in your calculator. So you're going to convert this into trigonometric. So just I rounded this one. Well, anyway, you can put here 77.45, then sine omega t, then minus 11.168. This one. You carry over, you copy paste this one here after the omega t. Okay? So that will be our answer. Okay? I'm sorry that I cannot discuss to you the very detail of the rectangular polar form. It's quite hard, no? For this very long to discuss this complex number. This is being studied in advanced engineering mathematics. Okay, so the answer here for number 1 is 77.5 sine omega t, okay, minus 11 degrees. Okay? So let's go now with number 2. Okay, the answer will be letter D. Let's go with number 2. Okay, for number 2, current flows through a circuit consisting of impedances AB and BC in series. The voltage of 150 volts between A and B lags the current by 30 degrees. And the voltage of 180 degrees between B and C leads the current by 50 degrees. assuming the current is the reference vector. Take note, if we mean reference vector, meaning that is 0 degree, find the resultant voltage between A and C, meaning that is the total voltage, no? So we have A, B, and BC in series. So let's have here for number 2. So we have 2 loads here. Okay. Let's say this is our point A, point B. This is our point C. So this is our load AB. Okay. This is our load BC. Okay. Paki-close up dito. Okay. So we are already given, no? The assuming the current is the reference vector. So reference vector natin yung kuryente. Our reference vector is the current here. Meaning the current here is 0 degree. That is our current I. Okay. So assuming the current is the reference vector. Okay. For the first, between AB, okay, AB, the voltage of 150 volts between AB lags. If we mean lags, what do we mean by lags? If there is a word lags, no, simply means that is below your reference vector, below. So we have here 150 volts. So we have 150. So ito po yan, 150 volts. Okay. So the angle here is 30 degrees. Actually, that is negative 30 degrees. No? Because it lags here. And the voltage of 180 volts between B and C leads the current by 50 degrees. So where is this? We have 180 volts here. One 80 volts. This is 150 volts. So this is how many degrees again? It leads 50 degrees. If we mean lags, that is below the reference vector. If we mean leads, meaning that is above the reference vector. Okay? That is above the reference vector. This is what we call the vector or phasor diagram, no? Or phasor or vector. This is being studied in advanced engineering mathematics. I have to apologize with if there are technicians, if there are high school graduate, no? This is an advanced study for you. Well, of course, you have to double your effort if you really want to become an engineer later on. So this is an advanced study for you. Do not expect that you will get this right away. No. Do not expect that. It really needs a lot of hard work. Just like us, no? A BSc graduate, no? I remember, third year na namin tong subject, yung AC circuits. That is a third year subject in a 5-year electrical engineering course. So, meaning, before you go to third year, you have to go first with first year and second year. Okay? So, you have to, actually, AC circuit is third year, second semester, I remember. That is a second semester. So, this is this is a third year, second semester. Because we need first to finish advanced engineering math before you go to to AC circuits. So, this is quite hard, no? If you go directly with AC circuit, no? But of course, you have to double your effort, no? Okay? In terms of mathematics. Okay? You want really to become an engineer because mathematics is the foundation, no? But just like what I said before, you don't have to be great in mathematics. Sir, is it need to be great in mathematics for me to become engineer? For me, it's no. You just have to be a math enthusiast. There's a big difference. Do I have to be an expert in mathematics? Do I have to be an expert in math for me to become an engineer? The answer is no. You just have to be an enthusiast. You just have to love mathematics. If we mean expert, these are great mathematicians, right? No need, you don't have to be like that. Don't have to be like that. You just have, your passion will get you there. Okay? So if you really want to become an engineer, no, you just have to study first mathematics, algebra, trigonometry, calculus, before you go to differential equation, before you go to advanced math. You see, there are so many math subjects you will go through first before you go with AC circuits. So it's very impossible for me because we have no free math review. I'm sorry. No? If you want a free a lecture in mathematics, there you have to enroll in our review program. No? So we can give the EE subjects for free to everyone. No? So this is already a big help to a student, no, who wish to become an engineer. But of course, you really have to take an extra step, a big step. No? It's not that easy. Okay? Kasi nga, third year, second sem pa tong AC circuit. No? Hindi naman tayo magsisimula sa algebra. No? So, it's impossible for me to explain this in a very clear manner. How do I say this in our language? I'm sorry because I am, what do you call this? Just like in computer, it's lag, what do you call that? It's buffering. Okay. So it's quite hard for me to speak the English language. No, I'm just trying, no, because of our intention. Because we believe what's the most important thing is the intention. We just want to help. Okay. So, okay, let's go over here. We already have the voltages, two voltages between AB and BC. Okay? At AB, so you have 150 volts that lags 30 degrees with respect to the current. And at BC here, the voltage at BC, you have 180 volts, no? With respect to the current I. Okay, take a look here, guys. Take a look here. Please take a look here. Okay. If I will get, the question is, find the resultant voltage between AC. Okay, so we have here, okay, so, ulat natin. This is VAC. Meaning, if you have a voltmeter here, okay, guys, there you are. So, we have here our VAC that is equal to VAB, okay, then plus BC. So, let's have this, okay, by advanced mathematics or by polar form. What is our VAB here? Our VAB is the 150 volts, right? Okay, so we have 150, put here, 150. And then var angle, so that should be negative 30 degrees. Again, this is from trigonometry. It's really very hard, no? To explain this in a very detailed, if I will going to touch the mathematics. This is, you have to study the trigonometry here. Say, well, what is positive, what is negative? When can we say it is positive or negative angle? That's a very long discussion. So, well, to make it a shortcut, so if you rotate this angle here, no? Okay, this is 0 degree. If the rotation is in, what do you call this? Counterclockwise, so that is a positive 50. Okay, from 0, that is a counterclockwise rotation, just like that one. But if the angle rotates in a clockwise direction, that is a negative angle. Negative angle. So that's why we have here 150, no? Negative 30 degrees, then plus. Then plus, you have your BBC here. What is your BBC here? So we have here 180, Okay? Because I've learned from our Zoom chat partner, no? Our participants are not all engineering students, right? They have different courses, and there are some are technicians or electricians. So you really need an extra effort for your mathematics here. Okay. Well, anyway, there are a lot of lecturers in the YouTube. No? They are big help. No? You can watch in the YouTube. No? You start with algebra. You start with algebra. So, okay, if you really want to become an engineer. So, okay, so do not go, wag kayong mag-advance math kagad, ha? Hindi. Kasi ladderized yun. Huwag kang mag-grade 6 nang hindi ka nag-grade 1. No? Algebra muna. Okay? So, we are here to help you guys. No? If you are electricians, you wish to become an engineer, we are here to help you. So, we have 180. What is the angle? 50 degrees. Positive 50. Okay. Again, mode 2 in our calculator. Press mode 2. Katulad nung ginawa natin kanina. Press mode 2 in your calculator. Mode 2. So we have 150 bar angle. Again, para lumabas yung bar angle, you have to press shift, then the negative sign. Okay? So we have negative 30. Okay, then plus 180. Okay, so we have here plus 180, then shift. So we have the bar angle, positive 150. 50 pala, 50 lang, sorry, 50. Okay, so that is equals. Okay, sa calculator ko, lumalabas kagad yung ano, hindi mo na kailangan mag-shift to 3. You want to convert into, in some calculator, you have to press equals, then shift to 3, no? Equals, no? Okay? So we have here, the answer will be 253.53. 253.53 bar angle. We have here 14.36 degrees in volts. Okay? So this will be our answer 253 or 254. Let's see, what letter is this? Okay, the answer would be letter C. Okay, letter C. Okay, so well, that's it for our part 1. We still have our part 2, no? So, thanks be to God for our part 1.